Okay, so on that same packet that your homework is on, if you look to the very back page, so number 7 and 8, you'll notice that these ones in particular ask you to use a graphing calculator and find all the things that we have been finding. But could you imagine trying to do this by hand? It would be kind of a nightmare. All right, luckily we have our handy dandy graphing calculators. So please turn yours on. Do you remember where you go to enter an equation? Right, you have to hit y equals, which is the top left button. So go ahead and hit that. Switch it with another one. If you have an equation already in there, just clear that out. We don't need anybody's old business. And we're going to go ahead and type in our new equation, 1.33. Do you remember how to do type in the variable? Where do you get the x from? What do you hit for an x?
The x key, whatever.
Yeah, it's the one right next to the green alpha key. So you see it says x, t, theta, and that's the button we use for a variable. So there's an x, and now you need to square it. Two options. You can either use the caret key with a 2, or there is an x squared button over here all the way on the left. So you can always hit that if you're going to square something. But any other exponent, you would have to use the caret key. So anyway, there's 1.33 x squared. Make sure you're using the minus button for minus 5.41 x, and then plus the 1.42. So hopefully yours looks like mine. If you need to, you can use the arrow to kind of scroll back and make sure you have everything in right. If you have something typed in wrong, nothing's going to match and we're going to be all confused. But mine looks like the given, so I'm happy. Okay, does everybody have theirs typed in? Please make sure that you stop me if you don't have what I have so that I can help you before I get too much further ahead and then you're super lost. So at this point, everybody has the equation typed in? Okay, great. How do I see it? Sure, hit graph. We have no idea what the window setting is from the last person that used it. So I got lucky, I can see mine. You might, who knows what the last person did with your calculator. If you can't see it, where do you go to just get the window back to being normal, 10 to 10? Yeah, you hit zoom, the middle button on the top. So if you can see yours, you don't have to do this. But I mean, you want to know how to do it because who knows when you're going to get a calculator and someone had the window set funny. You can do zoom, and then choice 6 will always bring you back to positive 10 to negative 10 on both sets of axes. Okay. If you can't see your graph, you could zoom in or out accordingly using that zoom feature. You can manually set the window if that's something that you need to do. But anyway, as long as I can see what I need to see, I'm pretty happy. So we're asked to find a couple of things. I want to find the vertex, the zeros, y-intercept, blah, blah, blah. Why don't we start with the vertex? Now, do you remember when we're talking about parabolas, we have a vertex that's either going to be a maximum point or a minimum point. Remember that? So in this case, this parabola has which? A max or a min? A min, because it bottoms out. It has a lowest point on the whole graph. So we need to remember that when we ask the calculator to find that point, because we have to choose between max or min. So if you pick the wrong one, you're going to get it wrong. So just make sure everybody's clear that this would be a min in this case, right? Because my thing bottoms out. So I'm looking for the lowest or the minimum point. Do you remember how to get to that window or that, Jake?
You hit the second blue button, top left, press trace.
Yeah, so if you look along the top here, you see this trace button, but you see the blue menu behind it, calc. That's where we're going to do all of our calculations. So let's all hit second and then the calc button. And this is basically all of the things that we want. We can find the zeros. We'll do that in a minute. You'll see choice 3 is a minimum, 4 is the maximum. That's why you need to know before you click in here which one you need. We said we needed a minimum, correct? So we're all gonna choose choice 3. When you do that, remember you get these funny questions. We did this when we were having them, when we did it with the funny graphs. So, oh, now you can't even see it. Just trying to move it out of the glare. Okay, so your calculator is probably gonna ask you left bound, and you'll notice there's this little blinky guy that pops up. If you use the left and right arrow keys, you'll see that blinky guy moving along your graph. See him? Use those left and right arrow keys and make them move around. Okay, so it's asking you left bound. Remember what that means. That's saying, hey, put the blinky guy a little bit to the left of where you think the minimum is. So where he is right now would be just fine. He's a little bit to the left of that lowest point. You hit enter. See that black triangle that pops up at the top here? See that? Now it's asking for the right bound. So you do the same thing, but now you move the blinky guy a little bit to the right of that lowest point. Hit enter. You're going to get another little black triangle up top. The calculator is saying to you, hey, I'm going to find you the lowest point between these two triangles. That's why it has you set this up. When it says guess, you can just hit enter one more time. You don't have to do anything with that. And then it will tell you exactly where your minimum is. Okay, so go ahead and copy that down. Let's go, oh, I don't know, how about 2 decimal places? I think would be fine. So I'd have 2.03, comma, negative 4.08. I also have my axis of symmetry from that. What do I write for the axis of symmetry? X equals 2.03. Do not forget the X equals part. You also, I mean, you can tell the domain from the graph is all reals, and you can also get the range once you have the vertex. The range would be, according to this graph, it would be, you got it, y is greater than or equal to that y coordinate, negative 4.08. Okay, the y-intercept is easy enough to honestly just do it in your head, right? Because you're just going to plug in a 0 for x. So wouldn't that just be 0, 1.42? So that one's easy. So the only thing I have left to do is find the zeros, but I bet you remember how to do that, or do you? Where would I go from here, you think? I go back to that calc menu, second calc, and this time I'm going to choose choice 2 because I'm finding the zeros. Remember that you can't find them both at the same time. You can only find one at a time, and you're going to go through the same steps. So one of my zeros looks like it's really close to the origin. It's not quite the origin, but it's close to it. So I'll find that one first. I'm just going to make sure I'm a bit to the left of it, and I hit enter. Now I'm going to be a bit to the right of it. So make sure I'm definitely on the right-hand side of that intercept. Look at your 2 black triangles pointing towards each other. Make sure that that x-intercept really does fall in between those 2 black triangles, right? If you drew straight lines down from those black triangles, if it's not in there, you're going to get the wrong answer. Yes, you just hit enter. Another nice thing to always check is that the blinky guy, they put him exactly on the intercept. So if your blinky guy is not where it's, if it's not exactly on that x-intercept, maybe you hit the wrong button. Maybe you actually hit, I don't know, max or min when you meant to, I don't know, who knows? But there's one of them. So I have x-intercepts at 0.28. Remember, that's just the first one. And then I do the same thing to find the second one. So everybody find your second one, and we'll see if we match. Make sure you're on the left-hand side and then on the right-hand side. And you always have to do it in that order, left first and then right. Oh, I'm so glad that this happened on mine. Yes. Yeah, so if you ever have this, see how, maybe look at your Y value. Maybe yours just says 0, or maybe it has something weird like this, like mine does. It has an E in it. This is the calculator's way of doing scientific notation. So this is literally a decimal, 11 zeros, and then a 1 on the end, right? So that's basically 0. I don't know why the calculator gets funny, but if you see an E in your answer in the ordered pair, it's just 0. So there's our other one, 0.379 or 3.79. Don't forget to do a quick sketch. Now that I have all my pieces, it should be relatively easy. Right about there. Where my x-intercepts are. Nice smooth curve as best you can. Bloop. So easy enough to find all these pieces. All right, cool. Try the second one. Now this one's got a whole bunch of fractions in it. Can I give you a word of advice? Well, I'm going to, whether you want it or not. When you are typing in fractions, oh, first of all, I guess I should have asked you this. How do I even get back to where I enter the, yes, you hit y equals. Go ahead and clear out the old equation. We don't need it anymore. When you are typing in fractions, it might be a little overkill, but it is never a bad idea to put the fractions in parentheses. Because funny things can happen. You want to make sure that I'm doing -3/8 times x squared. I don't want to have something weird like -3/8 times x squared. You know what I mean? And have all that in the denominator. So my word of advice to you, when I'm typing in a fraction, I just put it in parentheses. So they're right above the 8 and the 9, right? So I open a parenthesis and it's -3/8, right? So which is the negative button? Where's that? Where's the negative button? It's not the same as the minus key, right? Jake, where is it?
It's on the bottom row as a negative symbol and it's in parentheses.
Yes, that's the one underneath the 3. So anytime you want to type in negative blah, 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 that's the key you have to use. If you use minus, it's going to give you an error. So -3/8, so 3 divided by 8, and then close the parenthesis. That way there's no confusion about who's in the numerator, who's in the denominator, what's happening. So there it is, -3/8, and then just x squared. And then I can go from there, plus 1/3. So again, I just stick 1/3 in parentheses. Is it an absolute must? No, but I will tell you, you are way less likely to get, because when you're typing in the calculator, sometimes it can be weird. What's actually going in the numerator, what's not. Just save yourself the worry. Pop those fractions in parentheses. It's easy peasy. And there I have it. Go ahead and hit graph. Who knows what this thing's going to look like? Oh, wow. We got pretty lucky here. We can still see it on our normal set window. So does yours look like mine, first of all? Because if our graphs don't even match, we got a problem. Does it look relatively the same? Okay, go ahead. Try and find the things. I'm going to go through some of the steps just for the video. So if you don't want to listen to me, you can kind of tune me out for a minute. So Vertex, we hit second calc. Oh, wait, I forgot to ask myself, is this a max or a min? You guys tell me, is this a max or a min? This time it's a max because it's the highest point of the whole graph. So I'm going to go in the calc menu and I'm going to choose max, choice 4. Make sure the blinky guy's a little bit to the left of the max, hit enter. Put them a little bit to the right, hit enter. I got those 2 black triangles up top. The maximum point should be in between those 2. They are. Yes, you can just hit enter one more time. All right. There is my vertex. Round to 2 decimal places. 3.36. with that info, we already know the axis of symmetry. We know the domain. We know the range is going to be less than or equal to our y. The maximum. Okay, now
I got different
for what?
for the math, for the y though.
What'd you get?
I don't know, I got 1.42. Yeah.
You guys did?
Yeah.
Yes, some. Oh, so you can just do the two numbers divided. So for -3/8, you just do -3 divided by 8. Okay, let me look. Why are we getting different things? Did I type in something wrong? 1/3 x plus 23. Oh, I did 23/7, not 17ths. My mistake, my mistake. Good catch. All right, so then that's gonna change things for me. Still a max. Let me find pieces. Okay, so the x is the same, but yeah, 1.43. I didn't take my own advice and go back and check them before you do everything. Okay, and then 0 should be easy enough. Second calc, first 2. You can only find 1 0 at a time. I'll find the left one first. Okay. -1.5 is one of them. And then the other one, let's see. Show them on the left-hand side of that intercept. Show them on the right-hand side of that intercept. 2.40. And then y-intercept, there's no point using the calculator because you just type it in.
X to be 0.
Yep. So it's basically just whatever C is if you're in standard form. 0, comma, whatever that is. Okay, so double check your answers with my answers and let's make sure that we all got the same things. Make sure that your range is going the right way, right? It should be y is less than or equal to. Go super fast. I have a loop for us to take today.
Really?
Henry.
He thinks I'm going to search me, please.
Oh my gosh.
He is the bad influence.
Okay, any questions on this? Everybody get this to match? So if on your next test, there was a graphic calculator question just like this, you could get all these parts?
Yes.
Yeah, we're feeling confident enough? Okay, I mean, you could always do it by hand, but my gosh, when the values are
119.
not that nice. All right. Okay, so let's take a look at this sheet I just gave you. Okay, everybody. So there is one more form of a quadratic, and it's intercept form. Intercept form is great because it's basically just factored form. So it's very easy to convert from standard to intercept form. You just factor. And what is so nice about factored form is that although you don't just get the vertex for free like you do in vertex form, you get the x-intercepts for free. That's so nice. we call them P and Q. And so you'll notice, if I take this, right, and I solve it, if you're gonna factor that, you would get x minus 7, x minus 3. So what are the actual x-intercepts though? If those are my factors. X would equal what and what?
Oh, negative. Not positive.
Right, +7 and +3, right? So the important thing to keep in mind with P and Q is that it's always the opposite of whatever you see there. Just like when you're solving by factoring. Okay, so step 1, you're gonna factor. Now to find the vertex, it's really not that bad. What if the vertex, let's just say, so for this one, I have x-intercepts at 3 and at 7, right? I don't know exactly where the vertex is, but I kind of have an idea because it has to happen where? Where does the vertex have to be? Evan, go ahead.
X value of 5.
Exactly. The x coordinate would have to be 5. Wouldn't the vertex have to happen halfway in between the two intercepts? I don't know where, but somewhere along this line of x equal to 5, right? So now I at least know the x coordinate of my vertex is going to be 5 comma something. And then I can just take that 5, pop it in and see what the y value is. Okay, so I think if we kind of look down here below, I have some space for us to actually do it out. All right, so first we factor this. So what are factors of +21 that have to be -10? Pretend you don't know, that we didn't just talk about it. It'd be x what? You're factoring this?
Oh, -7, -3.
-7, -3, right. So the x-intercepts then are, we said 7 and 3, perfect. So now here we are talking about that vertex and axis of symmetry. So once you find your two x-intercepts, that's P and Q. So to figure out where the x coordinate of the vertex is, you just add them together and divide by 2. That vertex has to happen halfway in between those two values. So in this case, it's just 7 + 3 divided by 2. So that's how we get the 5. So now you know your vertex is at 5 comma blank. Now, to fill in that blank, you do need to take 5 and plug it. You can either put it into the original or the factored version. It doesn't matter. So go ahead and pop that in and tell me what you get out for y.
What do you plug it in?
Either one, either the original or your factored version. Because they're the same equation, right? So you're just going to take 5 and plug it in for x either here or here.
Is it -4?
That's what I got. Did you guys get -4? Or did you not do it yet? Check that you get -4. I believe that's what you should get. So now I'm going to plot some of these things on my graph here. I'm sorry that the graph is so dark, but I'm sure you can just make your dots real big. Or if you have a bright colored something. I'll try this pink one. We'll see how that goes. So I know I have intersects at 3. So one is right there. And then another one at 7. And now I found out that the vertex is at 5, -4. And it should all look pretty symmetrical already. Oh, that's funny. These are bright pink on the paper, but it comes up like black on the screen. Well, anyway, so if you are already, if your vertex is not like symmetrically in between those two, something's wrong. Okay, I can keep going over here. I know the axis of symmetry. That's easy enough now once I have that vertex. It's just got to be x equals 5. We can find the y-intercept easily enough. It's just got to be at 0 comma. What's my y-intercept this time? Evan?
0, 21.
Yeah, 0, 21. You just take 0 and pop it into the original for x, right? So unfortunately, that's going to be way off my graph. But if I were to sort of draw this parabola, it makes sense that my y-intercept is way up here at 21, right? That's a reasonable number. So even though I can't graph it on my graph because it's just way too high, I know I'm in the right ballpark. If I got the y-intercept with -3, that wouldn't make any sense with this graph. So I would know something is wrong. And that's it. Does it get harder than this? A little bit. Sometimes it can be a little bit trickier if A is not 1 and you can't factor it out from the whole thing. So let's flip to the back and let's see if we can try a few of these back here. So why don't we do, let's do B first together. You know this answer. They already gave it to you in factor form, so even nicer. I didn't even have to do that first step. You know what the x-intercepts are. What are they? -3 and a +1. I'm going to plot that on my graph. Remember, that is not an ordered pair, for the love of math. Those are just a list of my answers. So +1 is one of my x-intercepts, as is -3. There they are. So when I go to find that vertex, I know to get the x coordinate, it's really easy. I just add these two together and divide by 2. So what's that going to get me out? -1, right? -1. Is everybody okay with where that's coming from? Are you sure? Okay, now you need to figure out the y though. So I don't have the standard form to plug it into. So what? I'm just going to plug in -1 for each of my x's up here. So I'd have 2 times -1 plus 3 times a -1 minus 1. So if I just do that math out, that's what I get. Double check that that's what you get. Yeah, we're okay. All right. So, and also when I plot that, -1, -8. Just take a step back and ask yourself, okay, does this look like a parabola? I can't tell you how many times kids have the vertex completely wrong, and then they turn in some kind of, you can't even call it a parabola. It's like an S shape or some weird, I don't even know what you're doing. So it should look like a nice symmetrical parabola. It does. This is a good sign. If you had messed up, like let's say you messed up right here and you said +1 instead of -1, you're not going to have a vertex that lines up here. It's not going to look right. Again, math is always looking out for you. Axis of symmetry, you know that. X equals -1. Y-intercept, I can still plug in 0 for x. It's just not quite as easy as in standard form, but it's not bad, right? That would just be 2 times 3 times -1. It's not so bad. -6. Draw your curve. Everything's all right. You got to plug in 0 for x. And there it is. It's everything we thought it would be. Remember that A still tells you if it's up like a cup, down like a frown. So since A is just whatever your coefficient is out here. So it's a +2. So I was expecting this to be up like a cup. It is. That's always a nice, quick, easy check. The last one I want to do together is the fourth one, D here. Because this one we hit a little bit of a snag here. huh, A is not 1. I basically really need it to be 1 though, so I'm gonna have to force factor out a -1/2. It's not as bad as it sounds, right? So let's force factor that out. So I'm gonna have y equals -1/2 times, what's gonna go in here? Walk me through this. What would I multiply a half by, -1/2 by, to get back to -1/2 x squared? This first one's easy. This one's just. Okay, let me rephrase that. You're gonna take -1/2, which is what we're pulling out of the whole thing, and you're gonna divide each of these chunks by -1/2. Whatever's left is what goes in here. Wouldn't that just be x squared? Right? But now that one's easy. The middle one's trickier. What is this gonna be? What would I put right here so that when I distribute the -1/2 in, it comes out as a positive x? Jake?
-2x.
Yes, -2x. Right? If you distribute this back in, is it -1/2 times -2, a positive 1x? You can get that by dividing each of these terms by whatever you're pulling out. So take +4, divide it by a -1/2. What do you really get? Positive or negative? -8. Yes, and you can always check yourself by redistributing it back in. Just do the multiplication back, -1/2 x, yep, plus 1x, yep, plus 4. Yes, I know I did that part right. Okay, so that's important. I gotta force A to be 1 if it's not. But now look, I can factor this trinomial. Factors a -8 that adds to be -2. I can do that. Isn't that gonna be -6 and a +2? Oh wait, 4, just kidding. Oh wait. -4 and a +2, okay. Whew. There we go. I knew I'd get there eventually. So there is this same quadratic fully factored, but now I know where my x-intercepts are. Now I have it in intercept form. Where are my x-intercepts? At what and what? 4 and -2. So the vertex is going to require a little bit of work, but it's not that bad. Let me plot these two. So one of them is at +4 and one of them is at -2. So how do you find the x coordinate of the vertex again? Jake?
E plus q over 2, or you could graph your x-intercepts and then just count the middle.
Yeah, you get lucky when this is a nice number, right? So if I add them together, that's 2 divided by 2 is 1. When it's odd, then you're just gonna have fractions. I mean, whatever. So, but that only gets me so far. I have 1 comma, and now it's up to me. I do have to take that 1 and plug it back in. It should not matter whether you go back to the original or your factored one. They're the same equation. It's just 4/4 or $1. So plug in 1 wherever you like. I'll plug into the original. That's not so bad. So that's -1/2 plus 1 plus 4. So isn't that 4.5? Oh, no, wait, 5.5. Do you agree with me? Yeah, we're okay. All right, all I did was take 1, plug it back in, -1/2 plus 1 plus 4. Oh, because I wrote it. Oh, geez, Louise. That's why I messed up. Plus 4. That's why I was right, 4.5. Henry, why are you telling tales?
Oh, yeah, I'm with you, it's fine.
Yeah.
We're on the same page.
All right, now I know my x is symmetry, easy peasy, and then y-intercept, nice and easy, just plop in the 0 for x, and I get 0 for. All right, let's see if that vertex lines up with where I think it should be. 1, 4.5. 1, 2, 3, 4.5. This parabola is going to be down like a frown. Is that something we expect it to be? Yes, because A is negative. So if everything is not lining up to make the parabola go like I know it should be going, something's wrong. Thoughts? We're doing all right? Okay, why don't you guys try A and C? And when you are finished, you could submit this page as your homework. All right. Any questions right now?